Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring rotations in the coordinate plane. Before we do, let's review the definition of a rotation. So a rotation is a transformation that turns a figure about a fixed point called the center of rotation. An object and its rotation are the same size and shape, but the figures may be turned in different directions. So rotations can either occur in a clockwise, so going the same direction as a clock, or counter clockwise. And that would be the opposite direction that a clock moves in. So it would be turning this direction instead of the opposite way. Now, in example 1, it says the point 3, 1. So here's our point 3, 1 is going to be rotated in a counterclockwise direction. That means it's going to be moving to the left about the origin, 90 degrees, 180 degrees, and 270 degrees. And what we're going to do is we're going to fill in this chart. So our original point, we'll write that down as 3, 1. And it's not been rotated, so it doesn't have an algebraic expression. So we don't have to do those two columns. Now, when we rotate it, let's start with the 90 degrees counterclockwise. 90 degrees counterclockwise means to move your point 90 degrees or one quadrant to the left. And when we do that, we end up at point A. Now, point A has the quadrants of -1, comma, +3. And that was a 90 degrees counterclockwise. 90 degrees counterclockwise. Now, the algebraic representation of it, in other words, what is the rule here? Well, I want you to notice that the x's swapped places and the y's also swapped places, but the y changed to the opposite sign. So the way we represent that is we're going to swap the x and y. So instead of xy, we'll have yx, and then we're going to take the opposite of the original y value. The opposite of the original y value. So I'm going to put an opposite symbol right here. So our algebraic representation for a 90 degree counterclockwise is opposite y, comma x. All right. Now, what if it moves 180 degrees counterclockwise? So now I'm going to take this point and I'm going to go one turn would be 90 degrees to the left, two turns would be 180 degrees. So I move two quadrants to the left, and that would give me point B. And it is at -3, -1. Now compare it back to the original. This time, oh wait, I forgot to write down the degree. This was a 180 degree counterclockwise rotation. So now this time the x and y did not swap. The x is still with the x, the y is still with the y, but something did happen. The 3 became -3 and the 1 became -1. So opposite x, opposite y would be our algebraic representation of a 180 degree rotation. All right, our last rotation we're going to do is a 270 counterclockwise. So one rotation would be 90 degrees, another rotation would be 180, and one more rotation would be the 270. So that's 3 rotations. We moved 3 quadrants to the left. So that would be 1, -3. And that was a 270 degrees counterclockwise. Now, compare back to your original and notice that the X and Y swap places. So I'm going to put Y, X, and then let's see if any signs changed. So we went from +3 to -3, and then the 1 went to 1. So the Y stayed the same, but the X in this rotation changed to the opposite. So there's our rule for the 270 degree rotation. Now we're going to take these rules and we're going to apply it to an actual figure now. So in example 2, it says some common angles of rotation are shown below. Perform each rotation and complete the chart. So in our first rotation, we have a 90 degrees counterclockwise. Now look back up at the chart we made up here, and you can see here's your rule for 90-degree counterclockwise, and it is opposite y, comma x. Opposite y, comma x. So let's write that rule down real quick. That means the x and y are going to swap places, and we're going to change the sign of the original y. So in our new image, I would put the 1 here and the -y here. And notice it says the original y changes sign. So our original y was 1. So that means our new y would be the opposite of 1, which would be -1. All right. Now -5, 3. I want to swap places. So 3, -5. And then the original y, which is +3, changes to the opposite. So that would become -3. All right. Our last one, we have -1, 1. So swap places. And then the original y, +1, changes to the opposite. So that would be -1. Now let's draw our new image. Now if we do this correctly, our shape is going to move 1 quadrant to the left because we're moving counterclockwise. So let's draw in our shape. I'll put our shape in red. So we have a point at -1, -5. 4, 5. We have a point at -3, -5. And -1, -1. Let me draw that in straight as possible. So there's our 90-degree counterclockwise turn. All right. 180 degrees counterclockwise. Now go back up to your chart, and I want you to notice our rule for 180 counterclockwise is opposite of x, opposite y. So let's write that down. Opposite x, opposite y. So this would become +5, -1, +5, -3, and +1, -1. Now, 180-degree counterclockwise would mean we're going to move 2 quadrants, 1, 2, to the left. All right, so let's draw in our shape and see if that's what happens. 5, -1. 1, 2, 3, 4, 5, -1. 5, -3. So 5, 1, 2, 3. And 1, -1. 1, -1. So here's our shape. And notice that's exactly what happened. We turned once, and then we turned one more time to get us a 180-degree counterclockwise. All right, 270 degrees counterclockwise. Here's our rule for 270 counterclockwise. And that rule is y opposite x. So our x and y's are going to swap places, and we're going to change the sign on the original x. So this would become 1, -5. and then change the sign on the original x. So this would go to positive 5. All right, next one, swap places, 3, negative 5, then change the sign on the original x. All right, negative 1, 1, swap, and then change the sign on the original x. All right, now 270 clockwise would mean one turn would be in this quadrant, 2 turns would be in this quadrant, 3 turns would end up here. So let's plot that and see what happens. So 1 comma 5, 3 comma 5, 1, 2, 3, 1, 2, 3, and 1 comma 1 right here. So there is our 270-degree counterclockwise rotation. All right, now let's look at some clockwise rotations. Now, a 90-degree clockwise rotation would move 1 quadrant to the right, landing us right there. But I want you to look at our top row. One of our rotations also ended up in quadrant 1, and that was the 270-degree counterclockwise. That's because 90 degrees clockwise, if you were to go 1, 2, 3, you're actually ending up in the same place. So 90-degree clockwise is the same as 270 degrees counterclockwise. So I don't have to do all this work all over. I know that my coordinates are 1, 5, 3, 5, and 1, 1. And I know my shape was right here. It's the same exact rotation as the 270 degrees counterclockwise. Now, 180 clockwise. If I go 180 clockwise, I would go 1 turn to the right and then 2 turns to the right. And I would end up in quadrant 4. But isn't that the same as if I went 1, 2 counterclockwise? So 180 clockwise is the same as 180 degrees counterclockwise. So again, I don't need to do all that work we did in the top row. I can just copy down my points. 5, negative 1, 5, negative 3, and 1, negative 1. So 1, 2, 3, 4, 5, negative 1, and negative 1, 2, 3. So it looked like this. So 180 clockwise is the same thing as 180 counterclockwise. All right, now 270 degrees clockwise. That would be 1, 2, 3 rotations to the right. But that's the same as the very first one we did. The same as 90 degrees counterclockwise. Because if I just took this shape and rotated 1 quadrant to the left, I would also end up in quadrant 3. So again, I'm not going to redo all the work. I'm just going to copy from my top row here, negative 1, negative 5, negative 3, negative 5, negative 1, negative 1. Oh, and I forgot the rules here. Opposite y, x. This rule was opposite x, opposite y, and y opposite x. All right. Now, what do you think the rule for a 360-degree rotation would be? So let me use this as an example here. What if I did a 360-degree rotation? That would be 1, 2, 3, 4 quadrants. I would end up back where I started. So the rotation would be exactly as the original, x comma y. Nothing would change, all right? Now, what I want to do in this last part, what patterns do you notice? I want to put the rotations that were the same. So we know 90 degrees counterclockwise is the same thing as 270 degrees clockwise. 180 degrees counterclockwise was the same rule as 180 degrees counterclockwise. And then lastly, 90 degrees clockwise is the same thing as the 270 degrees counterclockwise. All right, example 3. The coordinate grid shows the parallelogram PQRS. If the figure is rotated 90 degrees clockwise, that means it's going to go one quadrant to the right about the origin to create parallelogram P prime, Q prime, R prime, and S prime. Which rule describes this transformation? So let's go up here. We know 90 degrees clockwise, that's right here, is the same thing as 270 degrees counterclockwise. And the rule was y opposite x. Y opposite of x. So now I know the answer is D. We know the x has to be the opposite. Let me highlight that. Because it's changing from quadrant 2 to quadrant 1. All right. Example 4. Describe the rotation. Describe the rotation and complete the table for each rotation. So in our first example, x, y, z was rotated how many degrees clockwise? So clockwise is to the right. So let's see. That would be 1, 2 quadrants. So that would be 180 degrees clockwise, or 1, 2 rotations would be 180 degrees counterclockwise. And the rule for 180 clockwise or 180 counterclockwise is opposite x, opposite y. Opposite x, opposite y. So our pre-image, 1, 2, 3, 4, 1, 2, 3. X was at -4, +3. Y was at -2, 2, 3, 4, 5, +6. And Z was at -2, +1. So if I apply that rule, I would take opposite x, opposite y. So my image would have to be at +4, -3. So let's see if we have a dot there. 1, 2, 3, 4, 1, 2, 3. Yep. -2, 6 would have to be at 2, -6. So 1, 2, 1, 2, 3, 4, 5, 6. Yes, we have a dot there. And then +2, -1. 1, 2. Yep, indeed we do have a point there. So 180 clockwise, same rule as 180 degrees counterclockwise. All right. In our next question, XYZ was rotated one quadrant to the right, so that would be 90 degrees clockwise, or 1, 2, 3, that would be 270 degrees counterclockwise. Now, the rule for 90 degrees clockwise or 270 degrees counterclockwise is y opposite x. Y opposite x. So I already know the coordinates for my pre-image. I'm going to copy them from the first table. They were -4, +3, -2, +6, and negative 2, positive 1. So the x and y are going to swap places, and then I'm going to take the opposite of the original x. So here the original x was negative 4, so in my image it will become positive 4. All right, do the same thing. I want to swap 6, negative 2, and then take the opposite of my original x. So that negative 2 will become a positive 2. Negative 2, 1 will switch 1, negative 2, and then take the opposite of the original x. So the opposite of negative 2 is positive 2. All right, example 5. Summarize the effects of rotations by writing sometimes, always, or never. So rotations, do they sometimes preserve the congruence of a figure? That's the same thing as the size of the figure. Do they always preserve the congruence of the figure, or never preserve the congruence of the figure? Well, rotations do not change the size of the figure. So rotations always preserve the congruence of the figure. Rotations sometimes change the orientation of the figure. In fact, they usually change the orientation of the figure, except for the 360 degree would preserve the original orientation. All the others will change the orientation. Okay, and then the rotations never change the orientation of a figure's vertices. Those will always stay in the same orientation. And that concludes today's lesson, rotations in the coordinate plane.